Hi everybody, welcome to lesson 4. In this lesson we worked with adding, subtracting, multiplying, and dividing polynomials, and we put all these operations together in one problem, which makes for fun exercises. So, number 1, perform the indicated operations to write each polynomial in standard form. Remember, standard form means that we have the highest exponent first, and the exponents decrease from there. So this first problem, I have this polynomial minus 4 times that one. If I think of my orders of operations, multiplying comes before subtraction, so I should probably multiply. And I'm going to distribute that negative 4. We're going to distribute in that negative 4 and get negative 4x cubed minus 28x plus 12x squared minus 4. Good. That first polynomial comes along for the ride. And I have no need for that set of parentheses anymore. And now we combine our like terms. When we can add and subtract, we don't touch the exponents. We only deal with the coefficients. So I've got 2x squareds here, 12 of them here. That gives me 14x squared. I've got a negative x cubed and a negative 4x cubed. That gives me negative 5 of them. So I have negative 5x cubed. Negative 9x minus 28x, that gives me negative 37x. Yes, I can subtract. And finally, 1 minus 4, last time I checked, was negative 3. Great, that's equivalent to what we started with. However, it is not in that standard form that I asked you to write it in. The highest power is this x cubed term, so he needs to come first. So by using the commutative property, we can rearrange these terms here in whatever order we'd like. This is written in standard form. That expression is equivalent to what we started with. They look different, but they're actually the same. This final expression is a much simpler thing to work with than that first one. The second problem here, I have x plus 3 squared minus x plus 4 squared. The big thing to remember is, how do I deal with something squared? Something squared means multiply it by itself. So I need to do x plus 3 times x plus 3. I can do that. X times x is x squared, 3x, 9. You can't do the thing that my 9th graders do where they just magically take that squared and get x squared plus 9. No, that's when I start throwing things, and I don't want to throw things. You can't make that silly mistake in Algebra 2. We need to be past that. So we have that first polynomial, which I'm going to put in parentheses, minus this second polynomial that happens when I square x plus 4. So it looks like I'm making another box. Stop whining, you had to make 2 of them. Alrighty, x squared, 4x, and 16. That wasn't so terrible, see? X squared plus 8x plus 16. Great, so now that I've squared both terms, I have to subtract by distributing that negative 1. So I get negative x squared minus 8x minus 16. Good. Who comes along for the ride? This guy out here. Distributing that negative 1 is the trickiest thing that it's so easy to make a mistake on, is forgetting to distribute that negative 1 there to subtract. Now we combine our like terms. I've got an x squared and a minus x squared. Those guys add to 0, so we say goodbye to them. 6x minus 8x is minus 2, because 6 minus 8 is negative 2. 9 minus 16 is negative 7. So that expression up there is equivalent to minus 2x minus 7. Not so terrible. Just working with polynomials that we've seen back in Algebra 1. Except now I can add in division, like I did here. So I have x squared minus 5x plus 6 divided by x minus 3, plus x squared plus x plus 1. Well, thinking about my orders of operation, I'm pretty sure division comes before addition there. So let's divide. You could do long division, or you could do the reverse tabular method like I'm doing right now. Either one works. If you get good at one, excellent. Use it. I will never force you to do something one way. Alrighty, x times x is x squared, because I stopped and asked myself, what times x is x squared? Well, x times x is x squared. That's a negative 3x. That's a negative 2x. Well, negative 2 times x is negative 2x. That's 6, it checks out. So what's my actual quotient there? When I divide those two, I'm left with x minus 2 plus x squared plus x plus 1. Combining my like terms, x squared plus 2x minus 1. That's my final answer. That trinomial there is equivalent to all of that nonsense up there. The fourth one here, I have x plus 3 times x minus 3 minus x plus 4 times x minus 4. Well, multiplication comes before subtraction, so I'm going to have to multiply those two terms together there. Well, how do I multiply polynomials? You've got it. Make a table. Alrighty, x squared. Luckily, these tables are pretty quick to make. Negative 3x minus 9. Good. So that purple piece is actually x squared. The middle term adds to 0 minus 9. Oh, wait a minute. If I think back to Algebra 1, that's just the difference of perfect squares. Minus, well, what does the blue give me? The blue gives me, let's see, x plus 4, x minus 4. X squared, 4x minus 4x minus 16. Good. That middle term also adds to 0 because this is the factored form of the difference of perfect squares. We will be factoring soon. Your favorite F word. X squared minus 16. Notice how I put them in parentheses because I have to distribute that negative 1 again. Minus x squared plus 16. Don't make silly sign errors like that because they cost you lots of points that you deserve. My x squareds add to 0, and I'm left with 7. Yes, 7 is a number, but 7 is also a polynomial. It's weird to think about it as a polynomial, but it is. The cool thing here, and I think it's cool because I'm a nerd, is that this expression is actually just the number 7. If you pick your favorite number and plug it in for x, 5, 10, a million, 22, negative 3, whatever number you plug in for x, it will always output 7 because we just showed algebraically that these two expressions are equivalent. Again, I think that's cool. You might not, but I do. Number 2, what is the area of the figure below? Oh, you're right now like, Coach, are you really making me do geometry? I just want to forget about that. Sorry, it's a good problem. Yeah, I mean, you have to think for a little bit, and the geometry is very minimal, I promise. So area. I don't know how to find the area of an L-shaped thing. So, wait a minute, what if I cut it like that? I know how to find the area of a rectangle. The area of a rectangle is length times width. Okay, or you could have cut it, if you didn't like cutting it that way, you could have cut it vertically like that. Your choice, I don't care which way you go, we should end up with the same answer at the end. So, I need to find the area of these two rectangles. I have the green rectangle, and I have the blue rectangle. Let's start by finding the area of the green rectangle. Well, area is length, 10x plus 30, times width, 6x plus 8. Not bad. I just have to multiply those two together. When I multiply polynomials, I can make a table to do the distributive property. 10x plus 30, 6x plus 8. Alrighty, let's see what we've got here. 10 times 6 is 60. X times x is x squared. 180x, 80x, 240x. So the area of the green rectangle there is 60x squared plus, add those two x's together, 180 plus 80 is 260x plus 240. Great, that wasn't terrible. Now I have to find the area of the blue rectangle. Okay, how do I find the area of the blue? Well, it's a rectangle again, so length times width. Wait a minute. I know I have a length of 2x plus 15. That's one of the sides. How do I figure out this piece here? Well, it's not 15x plus 10. 15x plus 10 is this entire length here. I don't want that entire length, I just want that blue piece. But wait a minute, this blue piece plus this green piece over here should give me that. So you had to recognize, I have 6x used up, I need 15, so I need 9 of them up there. I need 10, I used up 8, you have to kind of subtract to find that missing side there. Just a subtraction question. And if you did it the other way, you would have still had to do some kind of subtraction to find a missing side. Okay, so length times width now. I'll distribute because I already used a table. This area is 18x squared plus 4x. 9 times 15, I know you're reaching for your calculator right now, but that's okay. 15 times 9 is better known as 135. X, 15 times 2 is better known as 30. So the area of that little blue guy is 18x squared plus 139x plus 30. Okay, but the problem did not say find the area of rectangle 1 and rectangle 2. It said find the area of the entire figure. Well, what should I do with my two areas now? I need to add them together. So I need to do 1 plus 2. So how many x squareds do I have? There's 78 of them. How many x's do I have? Oh boy, 3-digit addition. I can handle this. 993, 399x. Plus, I know you just used your calculator, that's okay, plus 270. So that expression there represents the area of the entire figure, 78x squared plus 399x plus 270. Thanks for joining us for lesson 4. See you in lesson 5.